So वो तो basics and that's all about your O levels. ठीक है? So chemical equilibrium is you've got reversible reactions. So you've got reversible reactions, and what happens in a reversible reaction is, I mean, a lot of reactions are reversible. Just for example, some changes of state, like water turning into from liquid to gas. You're trying to boil water. Okay, that's kind of a reversible reaction, and it can be reversible at the same time. Okay, it would be going forward and backward, and it will be turning into steam. Okay, so that's a reversible reaction. So equilibrium is when the rate of forward reaction and the rate of backward reaction is the same, okay, in a reversible reaction. So if I have a container and that container has a certain amount of liquid water in it, and that liquid water is evaporating and it's turning into steam, ठीक है, तो gas के अंदर convert हो रहा है, and that, so you've got these particles of steam getting produced, and if it's a closed system, तो वो जो closed system होगा ना, these particles will condense back again at the same time. ठीक है, so if 100 molecules of water evaporate and 100 molecules of water they condense back at the same time, ठीक है, that means the rate of forward reaction and the rate of backward reaction is the same. तो उसका मतलब होगा कि उसका मतलब ये होगा कि you've reached equilibrium. ठीक है, at equilibrium the net quantity of water molecules in gaseous state and the net quantity of water molecules in liquid state will become constant. कि अगर 1000 molecules evaporate हो रहे हैं and at the same time 1000 molecules are condensing back again, so the net quantity of reactants and products will kind of remain constant. ठीक है? So coming back to this, okay, I've got पहले तो definition लिख लेते हैं equilibrium की. So the definition of equilibrium is that the rate of forward reaction equals the rate of backward reaction. So rate of forward reaction equals rate of the rate of equals the rate of backward reaction. And in a reversible reaction. Abdullah, क्या question है?
सर फॉरवर्ड रिएक्शन से मुराद के जो स्टेट चेंज हो रहे हैं.
हाँ, मतलब forward reaction यही है ना कि liquid to gas, that's the forward. Backward is gas to liquid back again.
Right, okay.
In a closed, in a closed system, तो ये उसकी ना definition of the rate of forward reaction. Remember, we're talking about rate over here, ठीक है? So rate of forward reaction equals the rate of backward reaction in a reversible reaction in a closed system. ठीक है, that is what equilibrium is. आपकी जो water bottle होता है, that's naturally at equilibrium. You don't see water evaporating, although it is constantly evaporating, but at the same time, it's constantly condensing back again as well. The rate of forward reaction, rate of backward reaction is exactly the same. Or when something is at equilibrium, the concentration of the particles will stop changing when something reaches equilibrium. So उसके बाद the concentration becomes fixed. So the concentration, or we can say the quantity of the particles or the moles of particles will stop changing will stop changing. Unaid, is this clear? Saad, clear है?
Yes, sir.
Achha, so it's going to stop changing, ठीक है? And it's going to be at equilibrium. Achha, so the other part is okay, this equilibrium can be disturbed if you ये जो equilibrium है ना forward backward, ठीक है? Right now it's at the same rate, ठीक है? But it's going to change if you change conditions, and that's known as Lee-Shatler principle. तो Lee-Shatler principle all उसमें पढ़ा था, that was के उसकी definition पहले लिख लें कि अच्छा Lee-Shatler principle, उसकी definition ये कि when the rate of forward reaction equals the नहीं rate कह रहा हूँ, वो तो equilibrium की definition थी, इसकी है कि the equilibrium opposes any change that's introduced to the system. So it opposes any change that's introduced to the system. What does that mean? It means कि अगर मैं temperature increase करता हूँ, which reaction will be favored? Evaporation or condensation? क्या होगा इस केस में if I increase temperature, if I start heating it up? मतलब क्या होगा इस कंटेनर में? हुनैद क्या होगा?
Sir, will the condensation increase, sir?
You're increasing temperature, higher temperature. Will there be more condensation? Will there be more evaporation?
Increasing temperature, there will be more evaporation.
Okay, so there's going to be more evaporation. Okay, so that means the equilibrium gets disturbed. What that means is, at a higher temperature, it's going to have a. इसको copy कर ले. अच्छा, so at higher temperature, it's going to have a lot more evaporation. Okay, compared to condensation. Condensation would slow down at higher temperatures, and there's going to be more evaporation, right? Rafi, clear? Amit, clear? अच्छा, there's going to be a lot more evaporation. और जितना ज़्यादा टेम्परेचर करते रहोगे ना, there's going to be more and more evaporation. So that means equilibrium is disturbed now. And if there is more evaporation, then that means there's going to be a lot more water vapors that will be formed. The quantity of water vapors क्या होते जा रहे हैं? ज़्यादा होते जा रहे हैं. Because the reverse reaction has slowed down at higher temperatures, right? So your equilibrium is now disturbed. वो एक साइड पे शिफ्ट हो गया, ठीक है? किस साइड पे शिफ्ट हुआ है? फॉरवर्ड साइड, ठीक है? It has shifted to the right. ठीक है? So what you're going to write is that it's shifting. I mean, your reaction is shifting to the right, or it's favoring the products. It's forming more and more. It's forming more and more water vapors. Is this idea clear? Abdullah, clear? Ahmed, Saad, clear?
Yes, sir.
Yes, sir.
So it's forming more and more water vapors, ठीक है? अच्छा, vice versa, if you decrease temperature, let's say you put it in a fridge, ठीक है? You lower the temperature, the equilibrium gets disturbed again. That's so if you decrease temperature, so there's going to be, so if you decrease temperature, then there's going to be एक से मैं देख लूँ, unmute देखो, नहीं मेरे एंड पे तो कुछ नहीं है, स्पेस बार कर लो या कुछ वैसे कर लो, स्पेस बार से अनम्यूट हो जाता है वैसे. I guess mouse से option है, it's how to unmute. मतलब मेरे end पे तो कुछ नहीं हुआ होगा. तो इसका chat के अंदर लिख देना. अच्छा, anyways, अच्छा, if you decrease temperature, then there's going to be more condensation, right? There's going to be a lot more condensation. और आपका जो ये वाला रिएक्शन है ना, evaporation slow down हो जाएगा because it's now colder and there's going to be a lot more condensation. ठीक है? So the amount of water vapors will decrease. तो ये कम होना शुरू हो जाएंगे. ठीक है? There's going to be a lot lesser water vapors because a lot of them are condensing back into liquid water. ठीक है? That means the equilibrium is now shifting to the left. तो पहले equilibrium जो right की तरफ shift हुआ था, it's now actually shifting to the left, and it's forming more and more liquid. It's forming more and more liquid water particles. ठीक है? अच्छा, ये क्लियर है? सारों को क्लियर है कि इक्विलिब्रियम शिफ्ट हो रहा है if you increase temperature, decrease temperature, right? Is that clear? This thing.
जी.
Yes, sir.
अब ये कि so what is the rule? The rule is, and you can make a general rule, which is कि whenever you increase temperature, the endothermic reaction is the one that's favored. The one increased temperature. So the reaction that is endothermic is the one that's going to be favored. So vice versa, if you decrease temperature. So the rule is that the exothermic reaction is the one that's favored. Okay, one of the reactions, they become faster compared to the other one. To increase karoge temperature, endothermic will be favored. Endothermic is evaporation. Evaporation is an endothermic process. And if you decrease temperature, the exothermic process is favored, which is the condensation part. Condensation where molecules lose energy. So when you lower the temperature, they'll start losing energy and they condense and they turn into liquid water. Okay? So ये पहला rule है. The Chatelier principle. Hopefully सारों को पता होगा. So is this clear? The first one, everyone?
Yes, sir.
There's a second rule. That's got to do with pressure. Okay? So, and that rule is the second rule, जो Chatelier principle का, that usually applies to gases. Okay? I mean, there's got to be a gas somewhere. So it's only for gases, or only if there is a gas present. So only for gases. तो ये जो rule है, that is कि if you increase pressure, so what happens is less gas mole side is favored, which basically means less gas is formed. So the side having fewer gas or lesser gas mole side, that's going to be favored. And vice versa, the rule is that if you decrease pressure, the more gas moles or more gas is produced, more gas mole side is so that is going to be favored. एक second और. So this one, this one only for gases. ठीक है? इसका मैं explain कर देता हूँ what happens over here. Same reaction. So I've got a pressure increase and pressure decrease, right? So I've got a container and it's got a movable piston. That movable piston is going to be used to increase and decrease pressure. So let's say the piston shaded 1 second. So anyways, this one. So you've got this piston over here. And the same reaction is happening. Let me move the piston upwards. And it's got liquid water in it, and it has exactly the same equilibrium. So there's H2O liquid, and it's the same equilibrium. The water is evaporating and it's producing gas molecules. And at the same time, the water vapors are also condensing back again. Okay? So you've got the same, exact same equilibrium that's taking place. मुझे explain करो, if I increase pressure, what should I do with the piston? If I want to increase the pressure?
Decrease volume.
So vice versa क्या होता है? It's always there's always going to be a decrease in volume, right? So if I were to increase pressure, so what will happen is कि or remember, liquids are incompressible. Gases are the only things that are compressible. So ये gas के molecules जो होंगे ना, they will become closer to each other. And I'm starting to increase pressure. I'm actually pushing it downwards. Okay? So the piston is moving downwards, and I'm increasing pressure. So I'm increasing pressure. Pressure जब ज़्यादा करूँगा, तो the volume will automatically decrease. And since you have a lesser volume, so gas भी कम बनेगी क्योंकि there is no room for gas to form, right? So if I continue to increase pressure, there's going to be less and less gas formed because there's no room for gas to be formed, okay? Because I'm decreasing the volume. So gas compress होती रहेगी, and eventually there would be no room left for gas to be formed. So the volume decreases. So automatically less gas would be produced, right? So is this idea clear that when you increase pressure, you're actually decreasing volume? So gas वैसी कम बनेगी. There's not enough space available. And vice versa, if you decrease pressure, तो आप क्या कर रहे हो? आप piston को ऊपर की तरफ move कर रहे हो. ठीक है, you're decreasing pressure. So you're slowly moving the piston upwards. When you're doing that, the volume automatically ज़्यादा होता जा रहा है. So there's going to be more and more gas formed, right? तो और ज़्यादा gas form होगी. जितना उसको और expand करोगे, because remember the liquids are incompressible. They don't expand, they don't compress. So nothing should happen to the liquid, but for the gases it does matter. Gases are compressible, ठीक है? Pressure कम होगा, decrease करोगे pressure, there's going to be more gas moles produced. Or the side that produces more gas moles, that's going to be favored. ज़्यादा gas form होगी. Vice versa, if you increase pressure, you're compressing it and less gas will be formed. So clear है ये चीज? अहमद, साद, मुनैद, अब्दुल्ला, clear?
Yes.
Yes, sir.
So that's for gas. अभी ये तीनों practice करते हैं. And then the last one, which is, so that's a rule number 2. ठीक है. As a rule number 3 is, if you try to decrease the concentration of a certain substance, एक second. So the final, now the final rule is that equilibrium does the opposite, that if you decrease concentration, of whatever the substance is, that's a final rule. So if you decrease concentration of anything, reactants or products, then what the equilibrium does is equilibrium does the opposite. The equilibrium will shift so that it can increase, will shift in whatever direction, but it will try to increase the concentration. It will try to counteract that. and vice versa. ठीक है, and vice versa. So if you decrease concentration, equilibrium will shift to increase concentration and the opposite. अच्छा, इसको भी उसी कंटेनर के साथ कर लेते हैं कि if I've got liquid water and there is liquid water and it's in equilibrium with its gaseous phase. यहाँ पे ना molecules बन रहे हैं and there's condensation happening as well. It's in equilibrium. If I have this container and all of a sudden what I do is I go in and I remove all the water vapors, right? So what's going to happen? So if I remove water vapors, it will try to form water vapors again. तो उनमें से ना एक reaction stop हो जाएगा. The condensation will stop happening because there's nothing to condense. So it will obviously stop. So for a brief instant, this reaction will completely stop because there's nothing to condense, right? But the evaporation will still go on. So what will happen is there's going to be more water vapors that will be formed automatically. So मैं अगर remove करूंगा ना, it will form those water vapors back again. ठीक है? तो इस और condensation फिर start हो जाएगी. क्योंकि once so slowly the condensation will start again. So if I remove water vapors, it will just form the water vapors back again. It will try to do the opposite. It will favor that reaction that will increase the water vapors back again. Is this clear as well?
Yes, sir.
Yes, sir.
The 13 rules and the Shatter principle. You studied this in O levels as well. Okay, so we're going to start doing some questions on this. Okay, so remember this. Rules ke, you increase temperature, endothermic is favored. You decrease temperature, exothermic is favored. This applies if the equilibrium has gases. If it doesn't have gases, this rule does not apply. Increase karoge pressure, less gas formed. Less gas mole side is favored. Decrease pressure, more gas mole side is favored. Okay? I mean, decrease pressure, the volume increases. So there's obviously going to be more gas produced. Increase pressure, the volume decreases. So you can't produce a lot of gas. और फिर है कि अगर किसी की concentration कम करते हो, वो दोबारा बना देगा उसे. आप water vapors को remove करोगे, so condensation immediately stops, but evaporation does not stop, and the evaporation will form the water vapors back again. अगर आप ज्यादा करोगे, अगर मैं water vapors को ज्यादा कर देता हूँ, तो condensation speed up कर जाएगी, और water vapors will automatically decrease. वो वापस उसी लेवल पे आ जाएंगे, ठीक है? तो आप किसी को ज्यादा करते हो तो उसको वापस कम कर देगा, किसी को कम करोगे तो उसको वो ज्यादा दोबारा से बढ़ा देगा, ठीक है? So let's start doing some questions on this. So starting with simple equations like like N2 plus. I've got N2. And it's in equilibrium with 2NH3. See, N2, all of them are gases. The enthalpy change is given. The enthalpy change is given as delta H being equal to minus 88 kilojoules per mole. Okay, so that enthalpy change is provided. I say enthalpy change जो given होती है, that's always for the forward reaction. Okay, this is always given for the forward reaction. The minus sign indicates that the forward one is exothermic. So we know that one of them is exo. So वो जो opposite होगा ना, the reverse one, that's going to be the endo one. ठीक है, is that clear? कि पहले तो ये figure out करना है कि which one is exo, which one is endo. So remember, enthalpy change will tell you that. अगर वो negative sign है, that's the forward is exo, and the backward is endo. Is that clear?
Yes,
Yes.
sir.
Yes, sir.
So अगला part here, let's change some conditions. Let's assume that it's at equilibrium. So let's increase temperature. So when you increase temperature, तो क्या होगा कि when you increase temperature, what's going to happen? कौन सा reaction favor होता है if you increase temperature? Endo or exo? ठीक है, remember endothermic is favored, right? Which in this particular case is the backward reaction. ठीक है, so that means the backward reaction becomes relatively faster. तो आपका जो backward होगा ना, that's going to speed up. It's the endothermic is going to speed up, and that means your equilibrium is going to shift to the left. N2 और H2 ना ज्यादा बन जाएंगे क्योंकि वो backward reaction जो है वो ज्यादा तेज है. ठीक है, so backward is favored, and that means equilibrium position shifts to the left or favors the reactants. To the left. अच्छा, equilibrium position छोटा करना है. अच्छा, ये equilibrium position shifts to the left. Clear है ये?
Yes.
All this.
So that's clear.
Yes, sir. Yes, all clear.
अच्छा, vice versa. Let's do another. Let's do decrease in pressure. So if I decrease pressure, तो वो क्या हमने पढ़ा था? What was the rule? If you decrease pressure, what's going to happen?
So forward reaction, the place where it's exothermic is going to be favored.
नहीं, decrease pressure उसका rule क्या था? कि it's more gas or less?
Right.
More gas or less gas?
More gaseous molecules.
ठीक है, so more gas mole side is favored. It's going to produce, because when you're decreasing pressure, you're increasing the volume. तो ज्यादा gas बनेगी. More gas mole side is favored. Side is going to be favored. तो आपकी जो दोनों साइडें हैं उसपे किस साइड पे gas moles ज्यादा हैं? You've got 2 moles of gas on the right side. And remember, or left side पे you've got 4 moles of gas. And remember, only count gases, 4 moles of gas. So more gas moles is the left side. So more gas mole side is favored, which in this case will be the backward reaction. So backward reaction favored. And so backward reaction favored, and you can write कि equilibrium position shifts to the left. एक सेकंड है ना. अच्छा, क्या equilibrium position क्या shifts to the left, right? और फिर आपके पास है you've got the third one. एक कर लेते हैं कि what if I decrease H2 concentration?
So it will favor endothermic.
नहीं, endothermic और exothermic तो वो इसको don't use the word endo or exo, use the word backward or forward. ठीक है, क्योंकि endo or exo ना you just use it for the temperature thing.
Okay, sir.
अच्छा, so if you हाँ, तो मतलब वो ठीक है, वो backward ही होगा. Decrease H2 concentration, right? So the rule was that it will try to make more H2. Equilibrium will try to do the opposite. the equilibrium will try to increase H2 concentration. As it tries to increase H2 concentration. So hence it favors backward. Okay, favors backward reaction. As it favors backward reaction, it tries to make more H2. Backward के अंदर more H2 is going to be formed. ठीक है. तो इसी की ना और practice. ठीक है. Remember, ये आखिरी तीसरा तो clear है ना सारों को.
Yes.
अच्छा तो ये वो levels का है. So we're just going to do more practice of this. We'll do some past paper questions. ठीक है. AS past paper questions. 1 second. अच्छा अब इसमें ये कि कहाँ पे इक्विलिब्रिया केपी ली शैटलर प्रिंसिपल ये वाला. अच्छा एक जो चीज है इसमें जो इम्पोर्टेंट है दैट इज सो लेट मी टेल यू वन इम्पोर्टेंट थिंग एंड दैट इज वन वेरी इम्पोर्टेंट पॉइंट. ठीक है. Before doing past paper questions, and that important point is that when we talk about forward being favored, equilibrium moving to the right or moving to the left, backward being favored, ठीक है. Remember, a comment on equilibrium is not a comment on the rate of the reaction. ठीक है. A comment on the equilibrium position, जब हम कहते हैं ना forward is favored, that does not mean that the forward speeds up. वो मैं explain करता हूँ what does that mean. So a comment related to equilibrium is not a comment on the rate of the reaction. ठीक है. रेट जो है ना वो एक अलग चीज है. अच्छा when you've got a comment on equilibrium, right? So when we say that's a relative comparison, ठीक है, that's a relative comparison. What that means is कि when I say forward is favored or forward speeds up, that just means that the forward is faster compared to the backward. So that जो equilibrium वाला part है ना, that's a relative comparison. So when I say that the forward reaction, for example, if I say forward reaction is relatively faster, या फिर forward is favored, ठीक है, or relatively faster compared to backward. तो इसका ये मतलब नहीं है कि the reaction is actually faster. It just means maybe both reactions are slowing down. Maybe the forward and backward are both slowing down, but the forward is relatively still faster compared to. So remember, it's a relative comparison. ये बात समझ आई equilibrium वाली बात सारों को. अब्दुल्ला हुनैद साद clear है?
Yes, sir.
ठीक है. So remember,
Yes,
an equilibrium comment is not a comment on the rate of the reaction. Maybe both of the reactions are speeding up, or maybe both of the reactions are slowing down. ठीक है. Rate of reaction is a totally different thing. So forward being relatively faster does not mean that it's actually faster. It just means that it's faster compared to the backward one. हो सकता है दोनों फास्ट हो रहे हो सकता है दोनों स्लो हो रहे हो. रेट के अंदर याद रख लेना कि रेट ऑफ रिएक्शन इट्स if you do these things, the rate of the reaction always increases. क्या क्या चीजें, if you increase concentration, increase temperature, increase pressure, तो एक concentration हो गया, एक हो गया आपका pressure हो गया. Pressure, remember, gases के लिए, because gases are the only things that are compressible, so it won't matter to the other ones. Temperature, So if you increase surface area, and lastly, if you increase if you add catalyst. This way, whether it's the forward reaction or the backward reaction, the rate will always, I mean, it's going to always increase. Or backward forward दोनों का ही. So when you increase temperature, चाहे वो backward है या forward है, it will always, जैसे ये वाला reaction ही था कि this ammonia reaction, the first one, right? So over here we were increasing temperature and the endothermic was favored, and I said that the backward reaction is favored, or we can say that the backward reaction is relatively faster, and the equilibrium position shifts to the left. Lekin when you increase temperature, the forward backward both speed up. ठीक है? Every reaction when you increase temperature, it speeds up. Backward is favored का मतलब है the backward is still faster, relatively faster compared to the forward. So is that clear? कि difference पता लग गया ना कि equilibrium और rate का क्या difference है? Is that clear?
Yes.
Yes, sir.
और इसमें ख्याल ये रखना है कि you have to keep your eyes open. Is the question about rate or is it about equilibrium? वो दोनों के अंदर ना बहुत confuse करेगा. So you have to be sure कि is the question about equilibrium or is that question about rate of reaction? Okay, वो clearly पता लग जाएगा, लेकिन बहुत सारे लोग confuse हो जाते हैं. So rate always increases, whether it's the backward or the forward. So अब थोड़े से वो question start कर लेते हैं. Let's start with for example, this question. We've got this question. So थोड़े से question solve हुए हैं. So I'll just yep. So you're saying catalyst का भी मैंने वो लिखा था, वो miss हो गया कि catalyst does not affect the equilibrium position. Just remember that. इधर add कर लेते हैं कि catalyst दोनों reactions को ना equally speed up करता है. So coming to this, catalyst does not affect equilibrium position. Instead, it speeds up forward and backward reactions equally. So it's equally. So catalyst, you got a catalyst, and it's saying what effect will a catalyst have on this equilibrium? First thing, it will speed up the forward reaction, right? It will also speed up the backward reaction. और ये वाला KP तो अभी हमने किया नहीं है, तो इसको छोड़ देते हैं. What does the catalyst do? It decreases, not increases, it decreases the value of activation energy. ठीक है? तो ये तो खैर, this was more about पहला वाला point ये भी हमने पढ़ा था. ठीक है? अच्छा, moving to the next question. ये clear है this question?
Yes.
ठीक है?
Yes, sir.
अच्छा, now this one, the percentage of ammonia. पहले simple questions ना कर लें एक second. ये वाला कर लेते हैं. Ammonia is manufactured. They're given us the reaction. What could contribute most to increasing the yield of ammonia? So you want to increase the amount of ammonia. So basically, you want to shift the equilibrium to the forward side, right? Increase ammonia, ठीक है? So should I add more catalyst? Will that increase ammonia? In चारों options, which one would be the correct one?
No, sir. No change, sir. Not the catalyst.
As a not a catalyst, because it's going to speed up the forward, but it will also speed up the backward as well, equally.
Mm-hmm.
So जितना ammonia बनेगा वो वापस it's going to get converted back into N2 and H2, right? What about increasing the pressure? If you increase pressure, what will happen? Less gas or more gas side? Whenever you increase,
Some less gas.
It will shift to the side with fewer gases molecules.
so less gas
So
concentrate.
it will shift to the ammonia. Yeah. Ammonia. Yeah.
So that means you got 2 moles over here of gas, and the other side is 4 moles gas. Okay. So it's going to shift in the forward direction, and that's fine. That will increase the amount of ammonia, right? So that's correct. Option D is correct. Increasing the temperature कौन सा reaction को वैसे favor करता है? That's endo or exo?
And endo.
So it's going to favor endo, and endo in this case will be the backward reaction. You can remember ये exothermic. It's the forward is exo, right? So and the enthalpy change is always given for the forward reaction. So using air rather than nitrogen. Not really sure if it will have any effect, but what effect will it have, by the way, वैसे, if you use air rather than nitrogen? Nitrogen जो है वो पहले, I mean, firstly you had 100% nitrogen. Air has how much nitrogen? Air has 78% nitrogen, right? तो आप क्या कर रहे हो? You're reducing the concentration of nitrogen, right?
Yes, sir.
So if you try to, so basically what you're trying to do over here in this case is you're decreasing N2 concentration. As I remember, concentration square brackets में लिखते हैं, so you're decreasing N2 concentration. So if you decrease N2 concentration, the equilibrium will try to make more N2, right? So it's going to favor backward reaction, right? Is that clear?
Yes.
The option B is clear. B
Yes, sir.
say होना clear है, ठीक है. साथ clear है.
Yes.
अच्छा, बाकी है कि there's another reaction which is he's saying the manufacture of sulfuric acid, SO2 and O2 and SO3 is formed, right? A bit of inorganic, we'll do that later, but you've studied this in O-levels as well. In one industrial plant, it is decided to change the pressure to 20. So you were using 1 atmosphere, and now you're using 20 atmospheres. So what are you doing? You're increasing pressure, right? Will the running cost increase? If you increase pressure, will the running cost increase?
Yes, sir.
It will, because higher pressure, that's expensive, right? You would have to make thicker pipes. There's more chances of explosions. So the running cost will increase. If you increase pressure, where will this equilibrium shift? You got 3 moles of gas on this side and you got 2 moles of gas on the other side. So if you increase pressure, to
The right
To the
side.
right.
to the right, right? So it will increase the sulfur trioxide percentage. So forward reaction favor hoga, and you'll get more SO3, right? So this number 2 is also correct. Number 1 be correct though. And the third one is the rate of backward reaction increases. Remember, forget backward or forward. Will the rate increase if you increase pressure?
Yes, sir.
So remember, this third statement is not about equilibrium. It's about the rate of reaction. Or rate of reaction kya hai? Rate always increases when you increase pressure. So it doesn't really matter whether it's the forward or the backward. Jo marzi reaction hai, its rate will increase. So over here he's saying, will the backward rate increase? Obviously it will increase. Agar wo yahan pe kehta forward rate increases, that will also increase. So this third statement was about the rate of reaction, and it always increases when pressure increases. Is that clear? This third one.
Yes.
Yes, sir.
So ठीक है, इसके कल हम फिर और practice करेंगे. We'll do more questions on this. Just the Lee Shatler principle, ठीक है? So कल continue करते हैं, ठीक है?
Okay, sir. Allah Hafiz.
Everyone, take care. Allah Hafiz.
Sure.
Haji.
So is there any link for the notes or the past year questions or the past recordings that I can check out, sir.
ठीक है, वो मैं सेंड कर रहा हूँ, ठीक है, मैं ग्रुप पे शेयर कर देता हूँ। ये जो
Okay, sir.
एक ये कि one thing is that you'll get access to this thing, ठीक है, ये you can get all the notes over here. I'll just share the link quickly. बल्कि अभी कर लेता हूँ, let me just stop the recording 1 second.